Alright, so here we are on the first page of the practice exam. These are pH, POH, H plus, OH minus problems, so make sure you have this square available. And you can type them in your calculator or you can do them in your head, however is good for you. And to go from HCl, remember that's the H plus ion concentration because it's a strong acid, to the pH, you would do negative log of 0.01, which is 2. And then the H plus ion concentration then would be 1 times 10 to the negative 2, or moving from pH to H plus on your calculator, what you would do is 10 to the x key and then to the negative pH, which is 2, which gives you 0.01, which is 1 times 10 to the negative 2. Then the OH minus, of course, is related right here, and so they have to add up to 14 up here, so this would be 1 times 10 to the negative 12th. Or if you wanted to do the math right here, you would do 1 times 10 to the negative 14th divided by the 0.01, and you end up with 1 times 10 to the negative 12th. So I did this equation right here to move there. All right, KOH, that gives us the OH minus ion concentration because this is a strong base. So to find the POH then, from the OH minus to the POH, I would do negative log of the 0.0007, enter, and so that gives us a POH right here, which of course is not on the chart, but subtract that or do 14 minus that and we end up with a pH of 10.84, and then the H plus of course would be 10 to the x key, second answer, and so we get 1.42 times 10 to the negative 11th if I'm doing it with the calculator. And then the OH minus right here, I'd do 1 times 10 to the negative 14th divided by the answer to get the OH minus. Well, I'm sorry, this is the H plus, and to get the OH minus, I take 1 times 10 to the negative 14th divided by the H plus, and I get approximately 7 times 10 to the negative 4th. Okay, let's see, going on to the CaOH2, the tricky part here is that this dissociates to give us 2 OH minuses because there's a 2 right here in the OH, and so that means that to find the OH minus ion concentration, I would have to take this concentration right here times 2. So 0.0005 times 2 would give me 0.001, or 1 times 10 to the negative third. That would be the OH minus ion concentration. And then to find the H plus ion concentration, 1 times 10 to the negative 14th divided by that answer, and I get 1 times 10 to the negative 11th. Notice that the exponents right here add up to 14, and then this would give me a pH then of 11, because the pH is the negative logarithm of this number right here. So don't forget to double it right here because there's a 2 below the OH minus. Solution with the pH of 5 would then be 1 times 10 to the negative 5th for the H plus, and then the exponents of course have to add up to 14, so this would be 1 times 10 to the negative 9th. Solution with the POH equaling 13, that would mean the pH would be equal to 1, and the H plus would be 1 times 10 to the negative 1st, and the OH minus would be 1 times 10 to the negative 13th. Notice once again those exponents have to add up to 14. You could certainly do this math right here on your calculator to confirm that. Okay, then next we're on to the strontium hydroxide one, and be careful of this one again because you're going to get 2 OH minuses when this breaks up because there's a little 2 right down here. So that means 0.005 times 2 would give us our OH minus ion concentration. So this would be 1 times 10 to the negative 2, or 0.01. Interchangeable, right? 1, 2. And then the H plus ion concentration would be 1 times 10 to the negative 12th. Take the negative logarithm of that, and that would be a pH of 12. For HBr then, we have an H plus ion concentration equal to whatever that concentration is. So that would be 0.003, or 3 times 10 to the negative 123. That's the H plus ion concentration. And so if we take the negative logarithm of 3 times 10 to the negative third, you would get 2.5. And so that's our pH, which would give us a pOH of 14 minus that answer. And so we'd have a pOH of 11.5 approximately. Would put me right here. And then to go to the OH minus, I could do 10 to the X key, negative answer, and I get an OH minus of 3.3 times 10 to the negative 12th. So did you see how I moved from here to here and then to here? Solution with a pH of 3 would give me 1 times 10 to the negative third for H plus, and then OH minus would be 1 times 10 to the negative 11th, because those two exponents have to add up to negative 14. You can do the math right between here if you want. And then, let's see, we're at a pOH of 11, so that means the pH has to be 3, right? Because 14 minus 11 gives me 3 for a pH. The H plus would be then 1 times 10 to the negative third, and once again the same. The OH minus would be 1 times 10 to the negative 11th. A nice little repeat there, but written a different way. BaOH2, one more where you have to be really careful because you get 2 OH minuses right there. And so then you have to double this to get the OH minus ion concentration. So 0.05 times 2, you get 0.1 molar concentration for OH minus, or 1 times 10 to the negative first. And so that means this is 1 times 10 to the negative 13th, and that means we have a pH of 13. All right, that's the pH problem, and there'll be something on the test exactly like that. Make sure that you're good at running your calculator and using the pH square, approximating. A weak base is dissolved in water. Number 2. Complete the table below and write equations in terms of X needed to calculate the pOH of a 0.5 molar solution of base. Make sure to set the equation equal to a number. So we're going to lose X. We will gain X here and gain X here. So 0.5 minus X, X and X. These would be the products. So that would be X squared divided by 0.5. Assume this is small compared to the 0.5. And that would equal our KB, which is 3.5 times 10 to the negative fourth. And then I would say I'm going to solve this for X. And this is equal to my OH minus ion concentration. And then I'd say what I'd have to do to find the pOH of it is take the negative log of this value. The negative log of the OH minus ion concentration would give me that value. Okay, one more of these problems right here. Weak acid is dissolved in water, and the weak acid, of course, would lose X, gain X, gain X. So I'd have 0.25 minus X, X, and X. End up with X squared divided by 0.25. Assume this is small in comparison, and set this equal to the Ka, which is 7.5 times 10 to the negative 7th. And then I'm supposed to find the pH, so I'd have to find this. And then I'd do the negative logarithm of whatever X is equal to the pH. So those kind of words right there with the filled in table will earn you full credit. Be back in the next video to start the multiple choice.